This is Chemistry 2, Unit 6 Solutions. Lesson 2, Part 2 on molarity, Video 2. So we're going to look at our last two example problems, and these ones are a little bit more in depth and a little bit harder. So this first one, anytime you see a problem like this one, we're going to follow this example. We are given a commercial solution, in this case of sulfuric acid, and we're given the percent by mass. We are given a density, and we want to know what the molarity is. So we are going to do something that we normally don't do with problems, but in this one, we are going to start with the density. So anytime you see this, where you're given a mass and a density and you want to know what the molarity is, you're going to start with the density. So we have 1.84 grams of solution per 1 milliliter of solution. So there is our density. Now we have to change this to molarity. And molarity is moles over liters. Right now we're in grams of solution per milliliter. So the first thing that we're going to do is change milliliters into liters. So there are 1,000 milliliters of solution per 1 liter of solution. That allows us to get rid of milliliters. Now, we have 1.84 grams of solution, and I am going to need to turn that into eventually grams of solute, or H2SO4, and then I can change it into moles of solute. The goal is to get moles over liters. I already have the liters. Now I have to get this to moles. So in order to go between grams of solution and grams of solute, the H2SO4, I have to use our percentage. So remember, the percent tells us that we have 100 grams of solution, and the 96.4 means that that's how many grams of H2SO4 there are in those 100 grams of solution. So that allows us to cross that off. And our last step, we don't want grams over liters, we want moles over liters. So I have to change grams of H2SO4 into moles. So I need the formula mass of H2SO4. And when you calculate it, you should get 98.08 grams in 1 mole. And that crosses those units off. And we're left with the units that we want. We want molarity, which is moles of H2SO4 per liter of solution. And when I calculate this out, here is our answer, rounded to significant figures, 18.1 molar H2SO4. So the H2SO4 that Mr. Duska and I order is this commercial brand, and this is the molarity of it, 18.1 molar. Our second example, we have the same substance, but we have different molarities, and we're going to mix these two. So I know that we have 25.0 milliliters of 1.50 molar HCl. If I pour that in and mix it with 35.0 milliliters of 5.70 molar HCl, I know that I'm going to get a molarity that is between these two numbers. So we have to use our definition of molarity. Molarity is equal to moles over liters to figure this out. So for each one of these solutions, I can't just add our volumes and add our molarities. Molarities can't be added together. We can't take an average of anything. So I know that I have a certain number of moles of HCl here in this first solution, and I have a certain moles of HCl in this solution. The moles can be added together, volumes can be added together, and since moles over a volume is molarity, I can calculate a new molarity. So I'm going to rearrange this equation, and I'm going to solve for moles. So moles are equal to liters times molarity. So for solution number 1, our number of moles is going to be, well, we're given milliliters. We have to change that into liters. So 1.50 molar times 0.0250 liters gives me 0.0375 moles of HCl. Solution number 2, we're given milliliters also, so I have to change that in the liters. So I take the molarity times the liters, and I get 0.200 moles of HCl. So now I can calculate our new solution concentration after they're mixed. So I can add the number of moles together, and I can add our volumes together, and when I divide the two, I get 3.96 molar HCl as my answer. That is between the two given molarities.